we were looking at the lines of best fit. And on all of them yesterday, I gave you a multiple choice question and said, which of these lines is the best equation? And we had to pick. Today, we are going to get the equation for that line ourselves. Nobody should be pushing anything on their calculators right now. All right, so there are a couple ways to do it. And you might have done this before, but you probably just took a ruler and tried to draw the best line that you could, and then tried to come up with the equation from the line that you drew. Okay, but if you remember doing that, we could all do it, and none of us have the exact same line because it wasn't a very accurate method. So there actually is a process for doing this, and we are going to have our calculator do all the hard work for us. So we just have to know how to use the calculator. However, like I already said, it's easy to mess things up so that it won't work. So I need you to be very careful on this. So, our example, we have the average temperatures in the northern latitudes. And I want the line of best fit. So, I am going to treat these as my x values and the temperatures as my y. Okay, so everybody has this notes handout in your binder. It's the last page in this unit. So on your calculator, so everybody has a calculator that looks like this. You are going to push stat. You see it under the delete button. So push stat. And then it comes up with edit, and we're going to push enter. So you should have something like this. You may or may not have numbers entered in there. Okay, if there are numbers in there, we need to get them out, but do not, under any circumstance, use the delete button, because it deletes the entire list out of the calculator, and it's annoying to try to put it back in, and it will mess up everything else we do. Okay, so don't do delete. What I want you to do, if you have numbers entered in here, if you use your up arrow, so it's on the title, L1, L2, and you push clear, enter, it will clear everything out of that whole list. Okay. Don't use delete, just clear. So now I'm going to go over to L1, clear, enter. So we should all have a blank looking table like this. Does everybody have that? Okay. Now what I want you to do is enter your X's in L1 and your Y's in L2. So you've got that table in front of you. These are ordered pairs, so they have to match up. You have to put them in order. Alright, so I don't even have a copy of it sitting in front of me. Alright, so remember our X's were sorry, I'm trying to find a copy so I can look at it and enter on my calculator. So my X's are those latitudes, so we're going to do 0, enter, next one was 10, enter, 20, enter, 30, so you put all the latitudes, those are our X's in L1, and L2 I'm putting my temperatures in the same order that they're listed on the table. So you can put one in, hit enter. When you're done, I'll put it on here. It should look like this. So you can double check yourself.
What are you doing now?
Putting all of these, so you didn't clear out this. Oh wait, you did. Okay, so you've got them all entered. So you're good. Just wait until all yours comes next. All right. Does Does everybody have all these entered in their list? Okay. So now, on our calculator, we are going to go back into Stat. And this time we want our calculator to do something for us. So we're going to go over to Calc. So just use your right arrow, highlight Calc. And we want the equation of the line. So this is linear regression. So you can either scroll down until you're on it, or you can just hit number 4. So we want the 4th one, linear regression. If you hit enter, it's going to come up with a list of information. Just use your down arrow, go to the bottom, and I have calculate highlighted, and hit enter. Yours may not have the R squared and R at the bottom. It kind of depends on what settings are turned on your calculator. You don't have to have those. Yep, we should all have the same numbers. Everybody get this?
Backwards? My A is 94.
Yeah, that's it.
Oh, you
Then go down.
you probably
What happened, buddy? There, Mom gets in here. First.
All right. So we are trying to get the line of best fit, and this really gives it to us. So it's y equals, and you'll notice this says AX, and then it tells me what A is. So A is our slope. Let's just round to 2 decimal places. So negative 1.07. Would the 1 cause me to round up or stay the same? Stay the same. So negative 1.07x plus b, which is the y-intercept. So that's 92.866. So I would round this to 7. So I have negative 1.07x plus 92.87. Did everybody get that line? And understand how I got my A and my B there? Okay. So then we can answer the second question. Estimate the average temperature for a city with a latitude of 48. So latitude, was that X or Y? X in my table, so that means my X is 48. So I'm going to plug that into my equation. Let's see what we get. Did you find it? All right, I got 40. What did you guys get? And what would my label on that be? Y was degrees Fahrenheit. That can't be right?
That's right.
Yeah, because the first one's a 1. Like, it's a 1 entirely, it's just a little higher than 1. So it should be
Wait, wouldn't that be
over
backwards?
48 instead of under 48. That's a 1. Why it's over right to be
Oh,
one.
yeah, okay. Yeah.
Oh. Alright.
All right. Other questions there? Okay, let's try another one. So in this, let's just make passengers the X, suitcases the Y. On my calculator, what is the fast way to clear this out? Where do I have to go first of all?
Wait, no, stat.
stat,
Stat.
edit. And then how do I clear these?
Up, clear, enter.
No, up, enter, clear.
No.
Alright.
It's
List,
not clear.
put your passengers for your X and your suitcases for your Y.
Wait, clear enter?
Uh-huh. It is also important to double check your points. If you mistype one point, it will give you an entirely different answer. Alright, did everybody get your data entered?
Yes.
And then where do we go to get the equation? Stat,
Cal.
calculate, and which one do we want? Number 4, the linear regression. And then on this, it's asking us a bunch of questions. As long as you haven't messed up your settings, you can just go down onto calculate and hit enter. And we get this. So stat, calculate, number 4. Alright, so y equals, what would I write for my slope here? 1.98x plus, what's my y-intercept? 1.97. Alright, and then part B, estimate the number of suitcases on a flight carrying 250 people. What would I do? Yep. So 250 people, that's my passengers, which was X. So we plug that in. I got 502.97. What does that represent?
Suitcase.
Suitcases. Can you have 0.97 suitcases? So what would I say? Round 503 suitcases. Okay. I want you guys to try the next one.
Just like do 12, 13, 15.
Okay. So the reason our numbers are so crazy, this is going to happen anytime we have years. And there is an easy fix. So instead of measuring the actual calendar year, usually we do like a starting point and the number of years after that. So there's different options. If you want to make it as simple as possible, I could just say this first one is year 0. So if 2012 is year 0, then 2013 would be 1, 2014.
3, 4, 5, 6, 7.
Okay, and you could also, like Jaden said, do 12, 13, 14, 15. Please write down, if you change those values, write down what you're changing them to so I can verify your equation. So if we go back into our list 1, let's change our x's to 0, 1, 2, 3, 4, and 5. and see what happens to the equation then. So I still get the same slope, but the y-intercept is now much more reasonable.
Hey, why is it positive?
Huh?
Why is it positive now?
Was it a neg? I think it was.
No,
probably-
it was positive.
No, last time it was negative.
It's
It was
positive.
negative. It was negative.
It was negative
No,
last
was
time,
it?
it was
No,
negative
it is.
300 something. See, but I'll really fight with this.
Okay.
What number on
Oh,
there?
what, you only go back?
How'd it make it a
again?
negative?
Show you?
Sure.
So, now we have to be really careful. When I say estimate the number of graduating seniors in 2025, what am I actually plugging in for my x? Because 2012 was year 0, so we're really finding how many years since 2012. So if I do 2025 minus 2012, since that's when we started, we get 13.
38.
So, if we, year 2025 is 13 years after we started. And then we also have to look and make sure our answer is reasonable. The first time we were talking about temperature, can temperature be decimals?
No.
Absolutely.
Wait, what?
In the very first example.
I'm stupid.
But on this one, we're talking about the number of graduating seniors. Could I have 0.45 of a graduating senior?
No.
No. So what would I call this? 457. Okay. Let's do. Okay, we're going to go ahead and do the next one, and then if we're okay with that, we'll probably go into C. Okay? So, everybody looking at this problem. This shows the Olympic 500-meter gold medal speed skating times. What would I probably want to change here?
The year.
So 1980 would be year. 1984 would be 1988.
8,
92.
12, 16.
Because the year goes from 80 to 84. So if you subtract them, 1984 minus 1980.
I was just going up on 4.
So everybody enter these. Let's see if we get.
Yeah, but how's the time?
Oh yeah, hold on. There's a mistake here.
What?
I know. This is what happens when I just listen. Huh?
I told you I was just
All right,
going up on
1994. That's how many years since 1980? 14. 1998 is 18. It didn't count by 4s the whole time. You have
Good
patience.
job, Jaden.
I don't want to take my time.
Well, that was all right.
I'm not gonna redo that whole line.
That's why I didn't type it in.
Don't try and mess it up. I'm telling you now, I'll mess it up so much.
The left is the X, right?
Yeah.
Oh my God.
Alright, stat.
She will not stop talking to you, I swear.
I'm doing my stuff, she would not quit bugging me, I swear.
420 enter.
I beat you.
She's bugging me too.
Alright, so the line of best fit, we get y equals a with negative 2.29x, b 430.56.
Oh, how did you do that one day? Huh?
Mine's 0.560.
Yeah, so is mine.
Um,
Mine's got
so,
something different.
part B, estimate the 500 meter time for the 2020 Olympics. So 2020
Oh.
would be 20, no, sorry, not 20. How many years since 1980? 40. 2020 minus 1980.
What?
What is that? That's under the 1980?
Dude.
Would it make sense to have a negative here?
No.
Or sorry, not a negative, a decimal.
Yes.
Yeah, when we're measuring times, we can have decimals. So we get 338.96. What is our time measured in?
Seconds.
Seconds. Woo! Okay.
I got that on lock.
Any questions on that one? The last thing I want to look at is the very last problem on here because it is different.
Oh.
Whoa.
So,
Increasing.
the last question
No.
gives us a scatter plot and asks us to write an equation. So we have to figure out how are we going to do that.
Oh, the point, we gotta do the points thing.
Okay, we
So
have,
490, yeah, 4.5.
okay,
No,
so could we estimate,
Sorry.
alright, I'm not gonna talk over you guys. So if I'm trying to figure this out, I have all the points here, they're just written in my graph instead of on my table, right? But we could put those in the table if we wanted. So we could think the year, tuition. Okay, let's say 90, let's make this year 0. Alright, so if that's year 0, what do we get out there? 4. Alright, so this would have been at, looks like this graph's counting by 2. So 2, this point would be 4.5. This is 4, 6. What's the point look like? Between 4.5 and 5, so 4.75. So I'm just trying to read all of these points from my graph and write order pairs for them. Okay, so this was at 8, 5, 10. The x-axis is counting by 2. Each of these are there wasn't a point there. So I'm just looking. So, yeah, I'm just writing the word here. So this one, my x, this would be 8, 10, this is at 12, and the y is 5.5. Okay, here's 14 and 6.
There's a many.
16, 7. 17, or not 17, 18, still at 7, and the final one, 20, is at 7.5. So if you have the scatter plot, you have to read the points from it. And now I'm going to put those in my L1 and L2. So then we have our equation. And then to finish it, it asks us. And this one wants to know the year in which tuition will reach 10,000. Is tuition X or Y? The Y. And it's already measured in thousands, so this is just saying the Y equals 10. So if we plug that in, we can solve it. What's wrong?
What? It's 10 for the 10,000?
We didn't
Yes,
use
and the
your
reason I
calculator.
didn't put the zeros, because this graph already says it's in thousands. Okay, let's just go ahead and round this. This would be about how many years?
37.
37 years. I'm giving you back your handout from yesterday. Remember, yesterday we did 2 questions. I did look at those 2 questions. If you have one of them circled, that means you have the wrong answer and you can fix it. The rest of them are like this, so you have the rest of the time to work on those.
Please, man, give me more of that. Wait, did I even throw one of them in? Oh, I don't want to do that. I understand. It's just- Wait, what? That's it?
this.
Goodness.
Just now, good.
What?